All right, geometry students, we're back here for section 9.6, dilations. Now, your previous studies of transformations in previous years, you may have studied about dilations, but we have to note that they are different than transformations because the size changes. Dilation, your figure is going to get bigger or smaller. All right, so let's get started here on the vocabulary. Identify four isometries. So our four isometries are a translation, a rotation, a reflection, and a glide reflection. Circle the answer to complete the sentence. A mapping that results in a change in position, size, or shape of a geometric figure is called a transformation. All right, scale factor. Scale factor of a dilation is what we're looking at right here. The scale factor of a dilation is the ratio of the length of the pre-image to the corresponding length of the image, with the image length always being in the numerator. All right, so this is always going to be image over pre-image. All right, so make sure you understand that. Image over pre-image. The image length always in the numerator. If the scale factor is greater than 1, the dilation is an enlargement. If the scale factor is less than 1, the dilation is a reduction. All right, so that is another huge part of this section. Which of the following shows a dilation? Okay, well, it certainly looks like this one does, right? So I start with a large skateboard and it gets smaller. The rings look about the same size. The roller skates look about the same size, so that is not a dilation. Which figure is transformed? When a figure is transformed by congruence transformation, what is true about the corresponding angles and the corresponding sides of the image and the pre-image? They're congruent, right? They are congruent to each other. The corresponding sides and the corresponding angles are congruent. Well, that's going to be different in similar figures. All right, a dilation. A dilation with a center dilation C and scale factor n, where n is greater than 0, can be written as a capital D, stands for dilation. Then in parentheses, in a postscript, we have n, and n is going to be the scale factor, all right, and C is going to be the center of dilation of a figure. So then a dilation is a transformation with the following properties. So the first bullet point says the image of C is itself. So C cannot dilate past itself. It's on itself. For any other point that is not at the center of dilation, so say R prime is on the ray CR, and the length of CR prime is N times CR. Or I have CR prime over CR, which is the image over the pre-image. So if we look at this distance right here, look at this figure, all right? Our original figure is the black one. So the distance from here to here is where we started. Our image is the distance from here to here. So I want to know what our scale factor is. Well, our scale factor is going to be image over pre-image. So this blue segment that I drew is longer than the black one I had. So it's going to be a bigger number over a smaller number, which is going to make this one right here a bigger number over a smaller number, which is going to make it bigger than 1, which is going to make it an enlargement. And you can see that this triangle got bigger to get to that triangle, right? The other thing about a dilation is that it preserves angle measure. So what that means is that the sides are in proportion and the angles are congruent. Well, what's that the definition of? That's a definition of similarity, similar figures. So our figures are going to be similar to each other this time. Instead of being a congruence transformation, all right, this is going to be what we're going to learn about later is going to be called a similarity transformation. Circle the equation that is true for the dilation. All right, so in this case, we're looking for image over pre-image. Which one shows an image over a pre-image? And that's going to be, that's going to be that one right there. So I have CX prime over CX. All right, so that's what I'm looking for. If you look at the rest of them, like this one right here, looks like I have a apostrophe on the top, so I have the prime on top, but notice that those segments don't correspond to each other. I have CY and CX. Okay, so that one's close to trying to trick you there. All right, a dilation is an enlargement if the scale factor n is greater than 1. The dilation is a reduction if the scale factor is between 0 and 1. I cannot have a negative scale factor. All right, so let's not worry about that. Okay, let's look at number 1 here. The dilation of scale factor n of the segment, or excuse me, around the origin of JKLM is going to give us J prime, K prime, L prime, M prime, an enlargement or a reduction. What is the scale factor? So if I look at this figure right here, which figure is the pre-image? What's my original figure, the black or the blue one? Well, the black one is. All right, the black one's my original figure because look at the names of the points. This is J, and this is J prime. Well, the prime one is our image. That's where we're going to end up. So I'm going from the black to the blue. Is it getting bigger or smaller? It's getting smaller, right? So I know it's a reduction. All right. So the image of J prime, K prime, L prime, M prime is smaller than the pre-image JKLM. So the image of J prime, K prime, L prime, M prime is a reduction. Fill in the blanks to identify the coordinates of the pre-image. So let's look at the ordered pairs of our pre-image. So J is 0, 2. K is 1, 2, 3, 4, 5, 6, 6, 0. L is 6, negative 4. And M over here is negative 2, negative 2. And now let's look at the points of the prime. So J prime. J prime has the point 0, 1. K prime is going to be 3, 0. L prime is going to be 3, negative 2. And M prime is negative 1, negative 1. All right. Do you notice anything about these points from here to here? Keep that in mind. Use the distance formula. All right, as distance is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. To find the length of the corresponding sides of the preimage of jk and j prime k prime in simplest radical form. All right, so let's go ahead and find the length of jk. So that's this side right here. Okay, so we'll use our ordered pairs. So we'll use these ordered pairs right here, right? So 6 minus 0 squared plus 0 minus 2 squared, right? So that's going to be, this is a little bit too much skipping here. So I'm going to go 6 squared plus a negative 2 squared. That's going to be 36 plus 4, which is the square root of 40. Two numbers I multiply together to get 40. Hopefully one perfect square. 4 and 10. 4 comes out. 2 radical 10. All right, so that's the length of this side right here, 2 radical 10. Now let's go ahead and find the length of j prime k prime. All right, so now we're going to use these 2 points. Okay, so I'm going to have 1 minus 0 and 0 minus 3 squared. All right, so that's going to give me 1 squared plus a negative 3 squared, which is going to give me 1 plus 9, which is the square root of 10. What do you notice about these two? All right, what do you notice? Well, the scale factor, my image, or excuse me, yeah, my image is going to be square root of 10, and my pre-image is 2 square roots of 10. Well, the square roots of 10 cancel. I'm left with nothing on top, which is 1 in a fraction world and 2 on the bottom. So there is my scale factor. What did you notice up here? To go from one point to the next, these 2 points cut in half, 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 right? We don't cut 0 in half. 0 stays the way it is. All right. And that's exactly how we can find the length of the sides by knowing that scale factor by looking at the ordered pairs. All right. Go ahead and pause the video and try this one here on your own. All right, is dilation n with the point x of triangle xtr equal to triangle x prime t prime r prime, an enlargement or a reduction? All right, is enlargement or reduction, and what is the scale factor of the dilation? Okay, now I guarantee that some of you out there got this wrong. All right, I guarantee it because I've been doing this problem for a long time and I know what happens. All right, so let's see what we got. So our pre-image is the black triangle, right? That's our pre-image. Okay. And then our image is this big bluey right here, right? Okay. All right. So what we want to do is obviously it looks like it's an enlargement, right? So it is getting bigger. So we know that these are out. Okay. So it's going to be one of these. Now we have to figure out what the scale factor is. So we need to figure out what the length of our new figure is of the sides that we know. Well, the length of this whole side right here is 12, and our pre-image was 4. So that's image over pre-image, which is 3. So the answer is B. I guarantee you there are some of you out there watching this video who put A, and you did 8 over 4. Well, 8 is only this portion of this side, right? It's just a piece of it. All right. So that is not the correct fraction to use. I have to use the whole length of the whole side. Okay. All right. In the warm up that we looked at, you got the dilation of a figure drawn in the coordinate plane. In this book, all dilations and figures in the coordinate plane have the origin as the center of dilation. Do you have to use the origin at the center of dilation? No. All right. But if you don't, then it just becomes a little bit more complicated. So for simplicity purposes, we're going to stick to the origin as our center. So you can find the dilation image of point P xy by multiplying the coordinates of P by the scale factor. A dilation of the scale factor n with a center of dilation at the origin can be written as this. The dilation, all right, with a postscript of n of xy is equal to nx times ny. So let's look at that in an example. Find the dilation image. What are the coordinates of the vertices of a dilation by a factor of 1/2 of triangle PZG? First off, if the dilation factor is 1/2, is it an enlargement or a reduction? It's a reduction, right? Because it's less than 1. 1/2 is less than 1. So I know my figure is going to get smaller. If for some reason I'm doing the problem, my figure is getting bigger, I'm doing something wrong. All right. Because it's going to be a scale factor of 1/2. Okay. All right. So that scale factor of 1/2 is we're going to use the origin as my center. All right. Because it's less than 1, I know it's going to be a reduction. So all I'm going to do is take half of my image, my pre-image coordinates. All right. So P, what's the coordinate for P? The coordinate of P right here is 2, 0. So I'm going to do half of 2 and half of 0. Well, half of 2 is 1, half of 0 is just 0. So that is my coordinate for P prime. All right. Z has the coordinate -3, 1. Right. So I'm going to do half of -3 and half of 1. Half of -3 is -3/2 or -1.5. And half of 1 is 1/2. So there's a coordinate for Z prime. And then G. All right. G has the coordinate 0, -2. All right. So I'm going to do half of 0, half of -2. Half of 0 is 0. Half of -2 is -1. All right. So I can now plot those 3 points. So I'm going to plot these 3 points up here. Okay. So P is 1, 0. Z is -1.5, 1/2. So it's going to be right there. So that's going to be Z prime. That's P prime. And then G prime is 0, -1. So there's G prime. So now I can connect. And there is our image. All right. You can see it got smaller because it's a reduction. And there are our points. All right. Okay, go ahead and pause the video and try this one on your own. All right, let's identify what our ordered pairs are here first. So let's do P. All right. P has the coordinate of 2, -1. All right. And that's going to change into P prime by taking our dilation factor, which is 2. So I'm going to do 2 times 2 and 2 times -1. So that's going to be P prime is now going to be 4, -2. Okay. All right. Now let's go ahead and do Z. So Z has the ordered pair -2, 1. Right. So Z prime, I'm going to just double each one of these. So it's going to be -4, 2. And then G has the coordinate 0, -2. So G prime, I'm going to double each one of these. So it's going to be 0, -4. All right. So now I've got my coordinates of my image. Let me recopy this one down here so we can see it all on the same graph. So there is G, there's P, and there is Z. Just because I know it won't fit on the big one up there. Okay. All right. So next, let's plot the 3 points that we have. So we have P prime, which is going to be 4, -2. 4, -2 be right here. So there's P prime. Z prime is -4, 2. So there's Z prime. And then G prime is going to be 0, -4. So there's G prime. So I can connect. Oops. I don't know what's going on there. Grabbing something I don't want to grab. There we go. And then we'll connect to there. There we go. Okay. I notice that this side right here happens to overlap with the previous one. That's okay. The reason is because it goes to the origin. Remember, our center of dilation is the origin. Okay. So that point that's right here, that's on the original black triangle, is not going to go anywhere because it's going to be dilated right on top of itself. Okay. All right. Great. Using the scale factor to find length. The height of a document on your computer screen is 20.4 centimeters. When you change the zoom setting on your screen from 100% to 25%, the new image on your document is a dilation of the previous image with a scale factor of 0.25. What is the height of the new image? Okay, so because the scale factor is 0.25, we know that this is going to be a reduction. All right, that's less than 1. So the scale factor of 0.25 tells you that the ratio of the image length to the actual length is 0.25. So our image over our pre-image, or image over actual, is going to be 0.25, right? So let's just fill in what we know. We know the actual length. So I'm going to have my image over our actual length, which is 20.4, is going to be equal to 0.25. If I multiply both sides by 20.4, that cancels out. Now it's exactly what I had right here, 0.25 times 20.4. All right. So I just pop that in my calculator, 0.25 times 20.4, and I get 5.1 centimeters. So now my computer screen, the file on my computer screen has now shrunk to 1.5 centimeters high instead of 20.4 centimeters high. Okay. All right. Go ahead and pause the video and try this one on your own. Just in case you can't see exactly what this says, this is 1.75 inches. Okay. All right, a magnifying glass shows you an image of an object that is 7 times the object's actual size. So the scale factor of the enlargement is 7. The photo shows an apple seed under the magnifying glass. What is the actual length of the apple seed? So if we look back over here and use this, image length over actual length equals 0.25. All right. So if we do image length over actual is going to equal the scale factor. Let's just plug in what we know. All right. Let's just plug in what we know. So we know that our image is 1.75. We don't know our actual, but we know that that's equal to 7. All right. Well, whenever I have that denominator as a variable, I can put that over 1 and turn it into a proportion, right? So now I can cross multiply. So if I cross multiply, I'm going to get 7x is equal to 1.75. And I'll divide by 7, and I'll get x by itself. So x is going to be equal to 1.75 divided by 7. All right, 1.75 divided by 7, 0.25. Okay, so this is going to be The actual apple seed is going to be 0.25 inches. Okay. All right. Good. All right. We're at the lesson check. So go ahead and pause the video, complete the lesson check, and then we'll talk about it here in a second. Go for it. All right. The gray figure is a dilation of the black one. All right. So if we look here, the gray figure is this guy here. It's hard to see the coloring there. Here's the black one. Okay. Use a diagram to complete exercise 17 to 22. Circle the image. Which one is the image? So the image is the one that has the primes, right? Circle the pre-image. The pre-image is the one that doesn't have the primes. Draw line segments to identify 3 pairs of corresponding sides in the image. We know that segment AB is going to correspond to segment AB prime. So now, how come A doesn't have a prime on it? Well, the reason is because A is the center of dilation, right? So A is going to stay on top of itself. AC, that corresponds to AC prime. And then BC, that corresponds to B prime, C prime. All right. This segment right here, B prime, C prime, is the only one that doesn't touch the center of dilation. So that one, the whole thing is going to change. Okay. All right. So we're going to find the side length. So what's the length of segment AB prime? That's 2. What's the length of segment AB? That's 8, right? This whole thing, 6 plus 2 gives me 8. The length of AC, that's 1. And the AC prime, is 1. And the length of AC, that's 4. Okay, so I always want to do image over pre-image, right? So the image, I'm going to have 2 over the pre-image, which was 8. And that reduces to 1/4. For AC prime, that's 1. And the pre-image is 4. So what do we notice? 1/4. All right, we get 1/4. So what is your friend's error? Your friend said it was 1/3. Okay, so once they did the same thing that some of you probably did on that multiple choice problem a few problems ago. All right, so they did not use a full length of a side. All right, so what they did is they did 6/2. All right, or excuse me, 2/6, and they did 1/3. Okay, but we know we have to use the whole side. This whole side here is 4. All right, we got to use that whole side. Just like this one, the whole side is 8. Okay. All right. A dilation. What's a dilation? All right. It's a transformation where the image and the pre-image are going to be similar to each other. It's going to get bigger or smaller. Okay. We need a center of dilation. So we need a point in which we're going to dilate from. All right. A scale factor of a dilation is going to be how much we're going to increase or decrease its size. If the scale factor is bigger than 1, we call it an enlargement. If the scale factor is less than 1, we call it a reduction. All right. Okay, go ahead and put a dot on the line of how well you understood today's material, and you are now all set to go ahead and work on the homework for section 9.6. Go ahead and get started on that. See you next time.